Hello everyone. Plan for this recording is to replicate our Zoom meeting. About 5 minutes left in the session. I realized, well, I was asked if I recorded it and I realized I did not hit record. So told everyone I'd go back through and do the problems that we did. There were some good problems. So it's about an hour recording here. It might not be quite that long, but that's how long the Zoom session was. So, all right. Here we go. First question we did was the extra credit, question number 5, which just asked me to solve this. So first step in solving something like this is, I notice I have a bunch of fractions. I don't want them. I need to get rid of them, or I'd like to get rid of them. So to clear fractions, you multiply everything by the common denominator. My common denominator between a 1, an x, and an x squared is x squared. In order to clear a bunch of fractions, multiply everything by the common denominator. So let's just distribute. X squared times 3 is 3x squared. X squared times 2 over x, this is over 1. I'm going to cross simplify. So one of these x's, or this x, will cancel one of these x's, and I have 1x left because that's going to go away, right? Because I have this x canceling one of the x's, so I have just 1x left. So 2 times x is just 2x. This x squared is going to cancel this x squared, and I got plus 1 left. Now, I left it at that, and they finished it. But let's just go ahead and finish. I would quickly try to factor this. So I'm going to go 3x and x. Factors of 1, 1 and 1. Since this is a positive, I'm going to multiply this times this and add it to this times this. 3 plus 1 is not 2. This is not factorable. Plan B. I'm going to do quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c. Notice how I did not write b squared. I wrote what the answer to that is, and I won't say always. Whenever I can, I will do that so I can avoid typing this in wrong. If you put that as b squared, then you are going to want to put that as parentheses negative 2 squared, because you need to square the negative sign also. If you write negative 2 squared, your calculator is programmed to know order of operations, and it will do 2 squared, and then it'll make it negative, and that is not what you want. You want to square the negative 2. Okay. All over 2a, and a was 3. So keep on keeping on. I get 2 plus or minus the square root of 4 minus 12, which is negative 8, all over 6. 4 minus 12. Now, looking at my answers, I see a bunch of real numbers. I don't see any i's. I know immediately answer is D. But if you needed to finish this, I would write this as 2 plus or minus the square root of a negative 1. The square root of 8 can break into 4 and 2. And I'm going to reduce that where I can. And so I get plus or minus I times 2, because square root of 4 is 2. The square root of 2 I don't know. It's some decimal, so I leave it alone. And that reduces down into 1 plus or minus I square root of 2 all over 3. I had some pre-made problems I need to get rid of. Okay, just to be clear, answer to question number 5 on the extra credit is D, no solution. If you could write i's and the answer allowed you to, then you should go all the way down to there if you had an imaginary option. or if it asked you to find all solutions and didn't specify real only. Okay, there's question 5. One more from the extra credit. Y equals question 16. Okay, question 16 on the extra credit asks me to find the inverse. So there's a couple things going on in question 16. We got to find, what is this thing called an inverse? Sorry, I'm having a hard time writing here. What is this thing called an inverse? How do I find it? And then how do I deal with logarithms? So there's two things going on here. First, inverses. To find the inverse, we switch the x and the y. So wherever you saw x, put in the y, and wherever you saw y, put in an x. So the y becomes an x, the x becomes a y. Now I'm solving. So the first step in solving is to undo what's being added or subtracted to what I'm solving for. I want this logarithm all by itself. So I have to get rid of the -2. So I'm going to add 2 to both sides. Adding 2 here makes this x plus 2. This becomes 4 log base 3 of y. I'm trying to get to the y. Before I can get to the y, I need to isolate the log, and then I can get to the y. So I need to divide by 4. Divide this by 4, divide this by 4. So I get x plus 2 over 4 equals log base 3 of y. Now, I'm going to switch forms. Remember from chapter 13, to switch forms, the answer to my logarithm is the exponent. This is asking the question, 3 raised to what power equals y? So this becomes 3 raised to the x plus 2 over 4 equals y. This base raised to this exponent must equal this number. That's super important. You can do that. That's on the test. So if I have the log base 3 of 9, my answer is 2, because 3 squared is 9. This number raised to this power has to equal this expression, or that number there. Okay, that's your answer. All right. Now, the next thing, people wanted another practice problem for something like that. Now, this one I made up just now. This is one I gave them, but this is one I made up. So if you're watching this and you were at the Zoom meeting, this is a bonus question. This is a little different than the one I gave during the Zoom meeting. You may, if you want to, hit pause and try this problem. Find the inverse will be the question. Find the inverse for this and this. Okay, find the inverse. First step, switch the x and the y. X becomes y, y becomes x. Solve or isolate the logarithm. So I need to get rid of this plus 6, and I need to get rid of this plus, or this times by 3. First step, subtract 6. This becomes x minus 6. Then I divide by 3. And I would have absolutely no problem. In fact, I would encourage skipping steps or combining steps. I would subtract 6 and divide by 3 at the same time, so I would go from here down to there. Okay, next step. I need to get rid of the log so that I can get to the y term. I can't touch the y until this log goes away. So I'm going to switch forms. 4 raised to the x minus 6 over 3 equals y minus 1. One last step, which was not in the last problem, but I don't want this minus 1, so I'm going to add 1 to both sides. Final answer, 4 raised to the x minus 6 over 3 power plus 1 equals y. If you haven't hit pause already, hit pause and try this problem. Find the inverse. Switch the x and the y. That's now a y, that's now an x. Now I want to isolate this exponential term. So I have to subtract 7. And remember how I said combining steps and divide by 2? I need to subtract the 7 and divide by the 2. Okay, now I'm going to switch forms. So here, to get rid of the log, I switch it to exponential. Now to get rid of the exponential, I switch to a log. So I have log base 5, right? There's my base. Answer to the logarithm is my exponent, so the y minus 1 comes over here. And this goes inside the logarithm. That's the hardest step, is going from, my opinion, is going from the exponential to the logarithm. And I'm just going to double check. Base to the answer, this is my exponent, so base to the y minus 1, looks good, equals that mess there. Okay, I don't want the minus 1 there, just like over here. So I'm going to take log base 5 of that mess plus 1 equals y. To find an inverse, switch the x and the y, and then solve for y. Okay. Next thing, we moved to the review and more logarithms. So remember how we did this one. This was back from chapter 13. We did one very, very similar to this. There was actually a third one in chapter 13. Okay, I'm going to start from the inside. This is question 12a. I'm going to start from the inside and do this first. So this is asking the question. I'm just going to rewrite it. I don't know the answer, so I'm going to call it x. So 3 raised to what power equals 81? That's what this question's asking. 3 to what power equals 81? Answer 4, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So the answer to this inside parentheses part is 4. Okay, same question. Different numbers, but same question. 2 raised to what power equals 4? And if you need to write it out, 2 raised to what power, put some variable in there, equals 4. Answer 2. Why? Because 2 times 2 is 4. Or 2 times itself is equal to 4. All right, there's the answer, 2. Question B, same idea. 25 raised to what power equals 5? Well, this is kind of a weird one. Normally, when I take a number and raise it to an exponent, it gets bigger. So how do I take a number, raise it to an exponent, and have it get smaller? So we have to start thinking about, well, what's the relationship between 25 and 5? Well, I know that 5 times 5 is 25, but how do I go backwards? Square root. So square root of 25 is equal to 5. So how do I write 25 as an exponent and have it represent, not 25 as an exponent, but 25 to an exponent, and have that represent the square root of 25? Remember back from, I forget what chapter, 25 to the 1/2 power means the square root of 25. So the answer to this is 1/2, because 25 raised to the 1/2 power means the square root of 25, and the answer to that is what I want, the 5. Good question. Chapter 13, we had some more like that, and this was a fraction. There was like 2 problems where this was a fraction. Good question. All right, on the review, we also did question 23. And the question asked me to find the equation of a circle with center at 4, -1, and a radius of 7. So, equation of a circle, x minus h squared plus y minus k squared equals r squared. That's my generic definition of a circle. I would definitely put that in your notes for the test. So what are h and k? H and k are the center of my circle, which is 4, -1. There's the x coordinate for the center. There's the y coordinate for the center. So x minus 4 squared plus y minus a -1 squared equals 7 squared. I'm not going to leave it like that. That's kind of messy. So x minus 4 squared plus y plus 1 squared equals 49. Negative is a positive. 7 squared is 49. So there's 23 on the review. I think that's all we did from the review. All right, chapter 14. We did several from chapter 14. Question number 7 out of chapter 14. Question number 7 asks me to graph the ellipse. Okay, so we're going to graph it. We're also going to find the focal point. Not that it tells me to, but just it's good practice. So let's graph this thing. Let's make ourselves a little XY axis over here. Whoops. Okay, so first thing, where is the center of this ellipse? First thing, I guess, back up. How do I know this is an ellipse? This is a plus sign. So if you have 2 terms that are being squared and subtracted and so on, sorry, added equal to 1, this is an ellipse. Remember my basic formula, x minus h, that typical one just like a circle, squared, over a squared, plus y minus k squared over b squared equals 1. Now that a and b can switch places depending upon which one's bigger. In this case, they do switch places, but that's my generic form. If what's underneath the if what is underneath the y is bigger, then this will be an a and this will be a b. Okay? All right. So h and k tells me my center, just like it did in the question before, of this ellipse. This doesn't have a parentheses squared, so my x value doesn't go anywhere left or right. My y value goes up 1. Notice that if it's y minus 1, the y value is up 1. Okay, there's the center. Now this tells me, the square root of this tells me how far to go in the x direction in both directions. The square root of this tells me how far to go in the y direction in both directions. So I go up 1, 2, 3, 4, and down 1, 2, 3, 4. I go left 2, and I go right 2. Putting in some numbers so that I have it labeled. Okay, now I'm just going to sketch my ellipse. Kind of make it as best you can. It doesn't go straight out like I did, but it's pretty close to straight out down there because this is pretty elliptical. Wow, that was too straight. I'm not going to take off if your ellipse is not perfect. Okay, that doesn't have, wow, that's horrible over here. You got the idea, right? Comes out and down. Okay, so there's my ellipse. This is my X, this is my Y, all that good stuff. Okay, my C values, my focal points are sitting here somewhere. Okay, my focal points are sitting in here somewhere. Where? So remember, in an ellipse, A is the bigger, so it's A squared equals, unlike Pythagorean theorem where C is the biggest, now it's A squared equals B squared plus C squared. And I'll let you watch the chapter 14 video to show why and how that triangle fits in here. Okay, so A is the 16, it's the bigger number. B is the 4, it's the smaller number, and I'm looking for C. So notice this is B squared. I don't square the 16, it already is squared. And the A squared is already squared. So I'm just going to plug them in. I'm going to subtract 4. I'm going to square root, and C equals plus or minus the square root of 12. Now what is C? C is the distance from my center to the focal point. So this is C. So my focal points are at the X coordinate, doesn't change, it's still 0. The Y coordinate was 1, but I added and I subtracted the square root of 12. And we're done. Had we gone this direction, then I would have taken 0 and added and subtracted the square root of 12, and the Y value would have stayed the same. Okay, question 6. Ooh, those are way too close together. All right, question 6. I rewrote this from what was on the paper. What was on the paper had this 76 over here, had the y's and squareds and x squared together. So my first step is to group the x's, group the y's, and get rid of the constant. When I say get rid of the constant, I mean move it to the other side. Okay, now I'm going to complete the square. Back from our quadratic unit, in order to complete the square, I take the coefficient of x, I divide it by 2, and I square it. So I'm going to add 4. Nope, sorry, I have one step before I do that. Leaving this alone for a second. Before I can complete the square on the y, the coefficient of the squared term has to be 1. This one already is, so I could have kept going, but let's make this one a 1. So I'm going to divide or factor out whatever's in front of here, even if it doesn't come out to be nice and neat. So I need to divide everything by 9. Well, lucky for us, it does come out to be a nice, neat number. 54 divided by 9 is 6, and I don't take it out of anything else. Notice my only parentheses goes around this right here. Okay, now I'm going to add 4. What I add to one side, I have to add to the other, so I'll add 4 over here. And this term right here, I'm going to take that, divide by 2, I get 3. 3 squared is 9, but that 9 is inside of a parentheses so that when I distribute it and I multiply it out, I would have a plus, wow, can't see that. I would have a plus 81 sitting right here. So what I really added over here was 81. So I'm going to add 81 right there. What I do to one side, I have to do to the other side. If there's a parentheses, you have to multiply what you added by what's outside that parentheses. Okay, this factors into x plus 2 times x plus 2, which I can write as x plus 2 parentheses squared. Leave the 9 alone. This factors into y minus 3 times another y minus 3, which I can write as y minus 3 squared. This is 85, minus 76 is 9. Now notice our exact, or our general form. It is equal to 1, not 9. How do I make this a 9? Or sorry, how do I make this 9 a 1? I divide everything by that number. 9 divided by 9 is 1. 9 divided by 9 is 1. And I don't have anything to divide, so it's just a 9. And you're right back to what we just did. Move it left 2, up 3, over 3, over 1, and I assume you can sketch that. Hardest part going from here to here. Okay, those are ellipses. How do I know? There's a plus sign here. So what if there's a minus sign there? What do I do? Okay, so now it's a hyperbola. So my first few steps are exactly like they are if it's an ellipse. So I'm going to go, I'll make some marks here first. 1, 2. Okay, I'm going to go left 1 and up 3. My center is left 1 and up 3. So there's the center of my hyperbola. This tells me to go 3 units in the x direction, both left and right. 1, 2, 3. 1, 2, 3. This tells me to go up 2 in the y direction in both directions. Okay? Next. If this was a plus sign, I draw my ellipse here and we're done. But it's not. So my rule is I need to make a box. So I'm going to draw a box around these data points, drawing vertical lines through these points and horizontal lines through these points and a vertical line through this point. Make a box. Now, notice I'm making them dotted because they're not part of my graph. They're just reference lines. And now I'm going to connect these dots. And I'm going to draw a diagonal line through the diagonals, or through the vertices, or the corners, another way of saying it, of my box. Okay? Both ways. So I'm going to go this way also. Yeah, my center is not very good. The one I drew for the Zoom meeting was great. All right, so I missed my center just a little bit, but that point is sitting right there. Okay, so this point is right there. My scale just got off a little bit. Okay, so there's my asymptotes, and here's my reference box. Next thing, since the x variable is first, rephrase that. Since the x variable is positive, it really doesn't matter which one's first. Since the x variable is positive, it opens this direction horizontally, you could say, like in the x-axis direction. So my ellipse is going to pass, or hyperbola is going to pass through that point that was right there, and it's going to come along this asymptote, pass through that point, curve, and head for that asymptote out there. Same over here. It's going to pass through that point right there and head for this asymptote out here. This side over here, for some reason, it's hard to draw. flattens out, and it keeps going. Okay, there's my hyperbola. Now, let's find the equations of the asymptotes. So back from a linear section. May have been in 055, may have been in high school algebra. There's equation of a line in point slope form. Most of the time, you're given an equation y equals mx plus b. And this one's great, but it's not as powerful as this one. This one I have to know the b value, the y-intercept, or I have to be able to find it. This one, I just need any old point. It doesn't even have to be the y-intercept, just any point works. And I need a slope. Well, I need a slope here too. So I'm going to use this equation. x1, y1 is just some point on my graph. Well, this point right here is my center, and they both pass through that center. So -1, 3 is 1 point on my graph, so I'm going to plug in -1 for the x, so minus minus makes it a plus, and plug in 3 for the y1. So x1, y1 is the point on my graph, x and y are part of my equation. Next thing, what is my slope? So notice how we did this one. I went up 2, because that's my change in y, and I went over 3, because that's my change in x, or my movement in the y and the x direction. So this slope is 2 over 3. And in this case, the one going to the right, this asymptote is a positive slope. Well, it's the same numbers, up 2, but now I'm going left 3. So my slope is both the plus and the minus, and I get both asymptotes because they both pass through that -1, 3. So I can use the same basic setup, just write plus and minus. Done. There's the equation for my asymptotes. All right, let's find my C value. My focal points. Your conic section will always wrap around the focal point. When we had an ellipse, it was inside and it wrapped around the focal point. Now it's a hyperbola and it's outside, so we wrap around the focal point. Okay, so what is this C value? Remember C, the distance from the center out to my focal point. That's my C value. So what is that distance? So C is now the longest, so it's back to your normal a squared plus b squared equals c squared. And if that doesn't make sense, go to the chapter 14 videos and I talk through all that. I'm assuming we can do that from when we're on the review. So a is 9, so sorry, a squared is 9, b squared is 4, c squared then is 13. And so c equals the square root of 13, or plus or minus the square root of 13. So now notice that my c goes out in the x direction, so I'll take the x coordinate of a -1, and I'll add and subtract. I'm going to go right, and I'm going to go left, the square root of 13. And my y value, the 3, does not change. There's my focal points. Okay? All right. And that's all we did. That was our Zoom meeting. Hope that helped, and I will post it.